Welcome back, everybody. Today's video is going to be a little unusual because I have to do what I have to do in a situation where I don't have a water hose and I need a motor to get cool quick. I've got to come up with a cool trick. Ooh, that was a rhyme. Nice. So, if you want to learn something about HVAC, today I'm going to be talking about this air conditioner, going over the schematic, and talking to you about what I have to do in the field. But first, I'm going to show you what I had to do because it didn't have water hose. But before we start, hit the bell. Ding! Like, share, comment. If you don't have a question, that's okay. I love your questions because I want to make content to answer those questions. But if you don't, say hi. Say hello. What's going on, Taddy? That helps me. Join if you want to support me. I really appreciate that. But let's get started. Without further ado, when you don't have a water hose and you have some duct tape because it fixes everything, you connect your conduit, your liquid tight, your flexible conduit to the spigot. You turn it on, boom, you're cooling the motor down because sometimes, well, you have a protection device on a motor just like you have on a compressor. And when a motor gets really, really hot, then it's going to open up the circuit and you're no longer going to have power going to the motor windings, powering the motor. So the motor is not going to turn back on until the protection device has reset. Only way to reset it is to get the motor cool. So I want to tell you, don't always think the motor's bad. Even though there's voltage going to it and it's not coming on, if it's not making a sound, check the windings. Know how to do that by checking out my playlist, HVAC Tips for Technicians. This right here is my conduit, and you can see I did a great job. No drips, no drips. That is an A for, oh, there's a drip, never mind. I get a B for effort. So anyway, it's cooling the motor off because it's super hot. If I had an infrared thermometer, a little infrared gun to shoot the temperature, surface temperature of that motor, I would check and see what it was. It's very hot to the touch. So, all right, let me show you what was wrong. This right here is a capacitor, and you can see it's not flat at the top like this would be flat. It's exploded, and that means that's an indication this is bad, and that's what was wrong. This is bad, okay? So what did I do? I used my meters. After I changed my capacitor, my compressor starts, verified it, sounds good, contactor, a little bit of carbon buildup, maybe need to replace this next. But I come over here on my defrost board and I've got my normally closed set of contacts that my line from my fan runs into. This comes from the contactor. It comes from T2, which is the load side of the contactor. And then it goes to my fan motor. So I pulled this wire off, and then I pulled the wire off of the fan terminal. This is my brown wire that goes to my fan. This motor has a 3-wire hookup, by the way. I'll show you on the schematic here in a minute if you want to learn. And then I've got my other wire from my fan, and it comes from the contactor as well on the load side of the contactor. So yeah, this was load side, load side. All right, let's go ahead and take a look at this schematic here. So CM means condenser motor, the one that exhausts the air out of the top of this package unit. It's got a black, a brown, and a purple wire. Black wire goes up, goes to T1. There we go. Then we've got the brown wire, which should go to F terminal of the dual capacitor. Look at that. Boom, right there. And then we got the purple wire. Look, let's follow that purple. Where's that purple go? Where's that purple go? All right, hold on a second. I just got lost. Purple goes up, take a left, go back down, take a left, go back up. Ooh, DF2. So that right there is a normally closed set of contacts. Like I said, it's got the 2 vertical lines and then the slash. If it didn't have that slash, it would be normally open. See, like those contacts there. But it's normally closed. And the defrost board sends power. So say I turn this back on after we get it cool and it still doesn't run. One thing you can check besides the capacitor, because we've already replaced it, is you can check voltage across these terminals. So what we would do is we turn it to volts AC. We would put, since this right here, this wire, this red wire goes back to this right here and to the common and line 2 are basically the same there. All right, so we would go from this terminal, all right, to this terminal and then to this terminal. And that's how you would check voltage. Or what you could do is you could go from ground, all right, which would be the cabinet, because the ground goes to the cabinet. Where is it at? It's right up there. See the ground? You could put one there, okay, 1 meter lead there, and then the other meter lead go right here. You should measure 120, and then to here, 120. We can do that here in just a second. I got to get this motor cooled down. I love this method I'm using here. This is just amazing. When you're in the field and you got 10 calls to do that day, if the unit's this close and you've got conduit and it'll work, make it work. That way you don't have to go back to the shop, or you don't have to go buy a new water hose. That way you can go ahead and get the calls done and get home when you want to, unless you get another call. Look at that. Oh yeah, that's nice. That's so nice. Hope you've learned something so far. If you haven't, you weren't paying attention. Let's get it cooled down, turn it back on. Also check the bearings too. But you would hear a sound, at least, if the bearings usually make noise, or it's hard for the blade to spin, shaft to spin. So if you don't know how to check bearings, you just take the motor, you flip it upside down, and you move the shaft, not up and down, but side to side. All right, let's get this cooled down. I'll turn it back on. All right, we're gonna plug our disconnects back in. Should come on right away. Fan is running. Capacitor was the problem. I didn't have a bad fan motor. I made sure that I cooled the motor off. I knew it was in a overload because, well, I know how to read the resistance of the windings, and usually you're gonna have an OL. So you need to know how to read the windings of the compressor. If you don't, check out my video on HVAC tips for technicians. Let's go ahead and use our meter. So now I'm gonna show you how to use your meter to measure voltage to the outdoor fan motor. So we're gonna measure two different ways. The first way we're gonna measure is from this side of the contactor to the wire that comes from this side of the contactor and goes to the defrost board, and this is the other side of the line to that fan motor, okay? So let's go ahead, and we've got 1 meter lead there, and then, all right, and then we're gonna take this meter lead and we're gonna boop right there. Should have 230 volts. And then right here, coming out of that set of contacts to the fan motor, 230 volts. All right, so now we're gonna measure from ground. So I take this, put it to the cabinet here, see that? And then take my other lead, and actually I can just do this right here. Ground, you can't really see it that good, but ground's right here. Okay, I'm touching it to the cabinet, and the other wire's right here. Okay, so 115 volts, and then go to the other side here. I gotta make sure I get this on camera so you can see it. There's to the other side, 115 volts. That's how I measure voltage to the fan. Let's go over how I measured that just now. All right, let me show you on the schematic where I put my leads for my meters, so you know, and let it make sense for the hookups for the outdoor fan. You gotta have both sides of the line, gotta have 230 volts, and that's what power we're supposed to provide this outdoor fan motor. This brown wire goes to the capacitor, the black and the purple, that's your line. One line, line 1 and line 2. So I measured from the black wire, okay, because one of these black wires goes down to the fan motor. I measured from this T1 terminal to, let's follow the red wire. Goes to the common, goes out, boom. This is to the outdoor fan. So I measured from that black T1 to this, and then through, got voltage, and then it goes back, purple, into my outdoor fan motor. So I got voltage, and that's how I read with my meter. Thank you for watching, and thank you to all my subscribers and everyone that's viewing my videos, giving me likes and comments. Thank you to everybody who's decided to support me, has joined my channel. I really appreciate it. Let me know what I can do to help you. And thanks for watching, and also, don't forget, this is Tad reminding you, I'll keep you cool if you let me.